Hello student, welcome to our third lesson. In this lesson, we are going to look at Newton's third law of motion. We start with the statement of the law. And this law states that for every reaction, there is equal and opposite action. Or in other words, for every action, there is an equal but opposite reaction force, which implies that if you have a body P and Q, and a body P exerts a force on another body Q, then that body Q will also exert an equal and opposite force on a body P. Now, it is very clear that it is due to action, that is the force exerted by foot on ground, and a reaction, the force that is exerted by earth on foot, that we are able to walk forward. And if one tries to jump ashore from a boat, he exerts a backward force on the boat, and the boat exerts an equal forward force on him. But you find that the boat moves backward because the frictional force between it and the water is quite small. And this backward movement of the boat reduces the forward force, and that makes the individual to fall on water. Now, the figure that we have here shows the action and reaction force that is acting on the block. If we look at this diagram, we have the weight of the block that is giving us the action, which is W is equals to mg. And then the weight that is being exerted by the table on the block is our reaction. And because there is no relative motion, or there is no resultant motion, then our R, that is reaction, is equals to the weight and is equals to the mass times gravitational constant. From there, we have that we look at the weight of a body in a lift. We start when the lift is at rest. Now, when the lift is not moving, the body that is inside is not also moving. They are all at rest. And therefore, the lift machine will read the weight or the actual weight of the body. And that actual weight is given by mass times gravitational constant. That will be the reaction, or that will be the reading of the machine. Then we look at the lift moving upward with an acceleration A. Now, for this case, the upward acceleration is positive, and the body that is inside the lift also is moving upward with the same acceleration. Therefore, we can get the resultant upward force that is produced by the acceleration as follows. We have that from the Newton's second law, F is equals to ma. The resultant upward force F will be equal to the total upward force P minus the downward force weight W. Remember, whenever we want to get the resultant force, we are adding, but we add as if we are adding vectors, because weight is also a vector quantity. So in other words, we consider the direction, which implies that if the force is moving upward is taken as positive, then the downward force will be negative. So in other words, our resultant F will be P minus W. So we make P the subject of the formula, which implies that P is equals to F plus W. But we know that F is equals to ma, that is from Newton's second law, and the weight is mg. So substituting or replacing these values in our equation becomes P is equals to ma plus mg. But again here we see that m is common, so we can factor it out. Therefore, our total upward force will be given by m into bracket a plus g. And this is what the machine will read, and also it is the reaction of the lift on the body. We look at an example. A girl of mass 40 kg starts on a scale balance in a lift. The lift is accelerating upward. If the acceleration of the lift is 2 meters per second squared, determine the reading of the scale. We start by writing our formula. P is equals to ma plus mg. We substitute the values. Our a is 2, our g is 10. So 10 plus 2, you get 12. Then you multiply by mass, which is given as 40 kg. You get that it is 480 Newton. This will be the reaction or the reading of the machine. Then we move to the lift moving downwards with the acceleration. So in this case, the downward acceleration will be negative. And that is why when you are moving down using a lift, you feel there is a feeling of being lighter. In this case now, the resultant downward force will be given by F is equals to the weight minus the total downward force P dash. Hence, we know that M, that is F, is equals to MA. So where we have F, we can put MA, then weight is mg, and then total downward force, we are using P dash. From here, we can make this P dash the subject of the formula, where we are taking these terms on the other side. We get that P dash will be mg minus ma. Again, m is common, we can factor it out. And when we do so, we get that m is equals to into bracket g minus a. That will give us the apparent weight of the body in a lift. And this again will be the reading of the machine. Then note the following. If the lift moves with constant velocity, whenever we say that the velocity is constant, it means that there is no change in velocity. If the body started with 2 meters per second, it will continue with that velocity throughout. And if the velocity is not changing, then the acceleration is zero. Because by definition, we know that acceleration is the change in velocity with the time. So if there is no change, then our acceleration will be zero. And that is why now the machine will read the weight of your body, because there is no change in acceleration, there is no change in velocity, and therefore the acceleration is zero. But if A is equals to G, that is the acceleration is equals to gravitational acceleration, in case of what we call the free fall, then the body will experience weightlessness. In other words, the reaction will be zero, because if G is equals to A, then this term inside the bracket will be zero, and when you multiply M by zero, you get zero. That's why now we are saying the reaction is zero, and the reading of the machine will be zero, and therefore the body will be weightless. Then during the landing of a spacecraft, acceleration is very high, and also the apparent weight of the astronaut. And for this reason, we find that the astronaut is strapped onto a cushion, and this cushion will prolong the time of impact, and therefore most of the force is countered. In other words, that force is reduced. Then from there, we move to an example. A body of mass 3 kg is attached to the hook of a spring balance that is hanging from the roof of the lift. What is the reading on the spring balance when the lift is moving upward with an acceleration of 0.2 meters per second squared? And number 2, when it is moving downward with an acceleration of 0.2 meters per second squared. And number 3, when it is moving upward with a constant velocity. We proceed as follows. We let T to be the tension. Therefore, the forces acting on the body are tension, that is acting upward, and the weight, which is acting downwards. So the resultant force acting on the body will be the tension T minus the weight. That is the total upward force minus the downward force. But this resultant force is our F, and F is equals to MA. So F will be T minus mg. We know that M is equals to 3 kg. Multiplied by 10, you get 30. And our A is 0.25 meters per second. So when you get 0.25, we multiply by 3, you get 0.75. So by making T the subject of the formula, we can say that it is, when you take 30 on this side, it will be 0.75 plus 30. Therefore, that gives us 30.75 newtons. And therefore, the spring reads 30.75. Then number 2, you're supposed to get the reading when the lift is accelerating downwards. So the resultant force will be the weight minus the tension. So our F will be mg minus T. So our MA, that is our F, MA, is equals to mg, that is 30 minus tension. But our A is 0.2. So 3 times 0.2 is equals to 30. That we are getting it from 3 times 10 minus T. So our T, that is the tension, will be 30 minus 0.6. Therefore, the reading will be 29.4 Newton. Then part 3, you're supposed to get the spring reading when the lift is moving upward with constant velocity. Now, we have seen that when the velocity is constant, acceleration will be 0. And therefore, our ma will be equals to 0. Therefore, m times 0 is equals to t minus 30. You get that our tension will give us 30 Newton. So the reading will be the weight, the actual weight of the body, because the actual weight will be 3 times 10, which is 30 Newton. So when we have that the acceleration is 0, therefore the reading of the machine will be the weight of the body. In this case, T is equals to 30 Newton. Then from there we have the assignment. Again, the assignment is testing what we have just covered. So practice, and you'll get everything. So thank you, and let us meet in our next lesson.